Hello Year 11 and welcome to our third video here for indices and logarithms. Logarithms for long, logs for short. This might be the first time we've spoken about them, but here we go. We use logs in a similar way to indices, and certainly they're closely related. We use some of the same language, particularly this idea of a base. Now, there's an example here in the notes here. 2 to the power of 3, right? A base of 2, an exponent, power of 3, equals 8. 2 to the power of 3 equals 8. We know that. 2 to the power of 4 equals 16. Right? But that should suggest that 2 to the power of something equals 10. Right? It's got to be some number between 3 and 4. Right? But what is it? Well, without calculating it for the time being, just knowing it's between 3 and 4, we can write that problem using logs. So we write this, we say that the log of base 2, right, the log base 2 of 10. Right, the log base 2 of 10 equals x, and x will be somewhere between 3 and 4. X is the number that I raise 2 to the power of to get 10. Yeah. So the log base 2 of 10 equals x, and we know in this case x would be somewhere between 3 and 4. So that's what logarithms are a way of expressing that relationship between a base and the exponents. So a to the power of b equals c. If that's the case, then the log base a of c equals b. That's the relationship there, in general terms, between indices and logarithms. Righto. So, let's get out of the road here. We're asked to evaluate the log base 3 of 9. Well, 3 to the power of what equals 9 is what we're being asked when we're asked to evaluate that. So I'm just going to say the log base 3 of 9 equals x for now, and rearranging it using this relationship here, that means 3 to the power of x equals 9. 3 to the power of what equals 9? 3 to the power of 2 equals 9. Here's another question here with powers of 10. Now we can solve this on our calculator because our calculator has a log base 10 function built into it. But we can do it without a calculator as well. So if I take this expression here and I just say that's equal to x, right, because that's what I want to find, then I might well say that 10 to the power of x equals 1,000,000. And I could in fact write 1,000,000 here as 10 to the power of 6. So 10 to the power of x equals 10 to the power of 6, therefore x equals 6. Rightio. Now, as I mentioned, we can use our calculator to evaluate logarithms, mostly just for a base of 10. So we can have logarithms with any sort of base, or at least any positive number. But my calculator doesn't have all of those functions built in, right? It has a log base 10 function, and that's written as log on your calculator. Now, my calculator emulator, sadly, has left me for the time being. So I'm going to have to talk you through this. Use your calculator to evaluate this to 2 decimal places. Now, I know that the log base 10 of 100 equals 2. So the log base 10 of 10 equals 1, 100 equals 2, 1,000 equals 3. So my answer is somewhere between 2 and 3. Right? We punch that into our calculator, and fairly neatly to 2 decimal places we should get 2.15. Okay, that's between 2 and 3, closer to 2. That's fine. Okay, so that's using our calculator, but it only works, at least for now, for a base 10. Now we're not quite done here. We've got a little more to go. Just to recap. So, what have we learned here today? Hopefully what we've learned is that we express logs in this term. This is the log base a of b equals c. Right? We can say it like that. We can voice it like that. The log base a of b equals c. And that's equivalent to saying a to the power of c equals b. Rightio. So that's our introduction to logarithms. It takes a little bit of getting your head around these things, just getting used to a new way of expressing those relationships. They certainly turn out to be a useful tool when we're solving all sorts of mathematical problems. Okay, that's it for today. If you've got any questions, please jot them down and ask me during our next meeting. Our next exercise after this is going to be on log laws. Okay, thanks very much. See you next time.